All right, get ready to dive into the world of mechanical engineering with us.
Sounds good to me.
Now, if you're picturing just equations and gears, oh boy, are you in for a treat. We're about to uncover a field that's all about creating life-saving devices, designing robots. Heck, you could even launch rockets into space with this kind of know-how.
The sky's the limit, right?
Exactly. And to make this journey even more fun, we've broken it all down into three easy-to-digest parts. First, we'll take a look back at some historical highlights, then we'll zoom into the future trends, and finally, we'll explore the cool and sometimes unexpected careers this field offers. So, to kick off our deep dive through the fascinating history of mechanical engineering, I'm joined by our expert who can explain even the most complex concepts in a way that even I can understand. And trust me, that's saying something.
Well, I appreciate the vote of confidence. I'll certainly do my best to make it clear and engaging. And you're spot on. It's not all just equations and technical jargon. At its core, mechanical engineering is about using creativity and innovation to solve real-world problems. It's about building a better future. And who wouldn't want to be a part of that? Speaking of problem solving, let me ask you this. What's the oldest machine that comes to mind?
The oldest machine. I feel like I should know this. I'm gonna go with the wheel. It just feels so fundamental.
You got it. The wheel, dating back to 3500 BC. It's amazing how such a seemingly simple invention revolutionized transportation and laid the groundwork for countless others. And the wheel's not alone. Those ingenious ancient Egyptians were using levers to move those massive stones around 2600 BC. And let's not forget about the water wheel, harnessing the power of flowing water by 100 BC. It's incredible how these early inventions showcase the inherent human drive to find mechanical solutions to the challenges they faced.
It really makes you appreciate how far we've come, but also how innovative those early engineers were. They didn't have computers or fancy tools, just observation, ingenuity, and a whole lot of determination.
Absolutely.
Yeah.
And their work laid the foundation for some truly remarkable minds to come. Take Archimedes, for example.
Oh, yeah. Archimedes, didn't he come up with that spiral thing for lifting water?
That's right, the Archimedes screw, a brilliant example of how effective a simple machine can be, and guess what? It's still used today.
You're kidding! That's amazing!
And that's not all. Archimedes' work on buoyancy, that force that makes objects float, was truly groundbreaking. Shipbuilding, submarines, even modern naval architecture all owe a debt to Archimedes.
Wow, talk about a lasting legacy. But before we get too caught up in ancient Greece, what about the Middle Ages? Were there any cool mechanical marvels from that era?
Absolutely. While knights and castles might dominate the history books, the Middle Ages saw significant mechanical advancement. Windmills and watermills, for instance, weren't just whimsical features in the countryside. They were essential for grinding grain, powering sawmills, and even irrigating crops, the renewable energy sources of their time.
It's fascinating how these inventions, which might seem simple to us now, were so central to everyday life back then.
Precisely. And let's not forget the development of mechanical clocks, a major leap forward in timekeeping.
That must have been a game changer. Imagine going from sundials to these intricate mechanisms that could tell time with much greater accuracy.
Exactly. And this leads us to the Renaissance, a period bursting with creativity and innovation, embodied by the ultimate Renaissance man, Leonardo da Vinci.
Ah, Leonardo, the artist, the inventor. How does he fit into our mechanical engineering story?
Well, da Vinci's genius wasn't limited to art. He was deeply fascinated by mechanics. His notebooks are filled with sketches of flying machines, war machines, gears, levers, all centuries ahead of their time.
It's incredible how those ideas existed in his imagination all those centuries ago. It really shows that mechanical engineering isn't just about building what we know, it's about envisioning what's possible.
You've hit the nail on the head. That spirit of innovation fueled the Industrial Revolution, a period that transformed our world and the course of mechanical engineering forever.
The Industrial Revolution. Now we're talking steam engines, factories, mass production, all those things that completely changed the way we live and work.
Precisely. This era marked a pivotal shift from manual labor to machine-driven manufacturing. The steam engine, in particular, was a complete game changer, powering factories, locomotives, ships. It was a marvel of its time.
It's amazing to think that a single invention, the steam engine, could have such a profound impact.
It certainly did. And it wasn't just about the machines themselves, but also about the scientific principles driving them. This era saw the development of thermodynamics, which was crucial for understanding how energy works, especially in these new machines.
Thermodynamics. Now, you promise to keep it simple, right? That word takes me right back to high school physics, and it wasn't pretty.
Of course. In the simplest terms, thermodynamics is about how energy, particularly heat, is transformed and used to do work. Think about the first law of thermodynamics. Energy can't be created or destroyed, only converted from one form to another, just like in a steam engine, where heat energy is converted into mechanical energy to power those pistons.
Okay, I think I'm starting to remember this. So energy doesn't just disappear, it changes form. What about the second law, though?
Great question. The second law can be a bit trickier, but essentially it says that whenever we convert energy, some of it will always be lost as heat, meaning no machine can be perfectly efficient. There's always some loss to the environment.
That makes sense. So even with these incredible machines, we can't escape the fundamental laws of physics.
Exactly. And these weren't just abstract theories. These laws had a real impact on how engineers designed more efficient engines and machines. They paved the way for the even more sophisticated technologies that we rely on today.
I'm ready to hear about those modern marvels. But before we journey into the future of mechanical engineering, we're going to take a quick break. Don't worry, we'll be right back to continue our deep dive into this fascinating field. And we're back, ready to jump into the future of mechanical engineering.
It's a wild ride, that's for sure.
After that incredible trip through history, I'm so curious to see where this field is headed. We're talking robots, artificial intelligence, sustainable energy solutions. It seems like the stuff of science fiction, but it's becoming our reality thanks to brilliant minds in mechanical engineering.
You're absolutely right. It's an exciting time to be a part of this field. And we're not just talking about small steps forward. These are innovations with the potential to solve some of humanity's biggest challenges.
Okay, now you've really got my attention. What are some of these game-changing trends we should be keeping an eye on?
Well, we could talk about this for hours, but let's focus on 6 key areas that really highlight the breadth and impact of modern mechanical engineering. First up, we have automation and robotics.
The robot revolution, here we come.
Exactly. And this is transforming everything from manufacturing to healthcare. Then there's sustainable and renewable energy, a critical area as we transition towards a greener future.
Two huge areas with huge potential impact for sure. What else is on the horizon?
We've got advanced materials, think lighter, stronger, more durable materials that are going to revolutionize everything from how we build airplanes to how we create medical implants. And of course, we can't forget additive manufacturing, better known as 3D printing.
Ah, yeah, 3D printing, it always feels like one of those technologies with even more untapped potential.
You're right, we're really just scratching the surface of what 3D printing can do. And finally, 2 super exciting areas pushing the boundaries of what's possible. Biomechanics and biomedical engineering, where engineering meets the complexities of the human body. And the integration of artificial intelligence and machine learning in every corner of mechanical engineering.
Wow, that's a lot to process. It sounds like mechanical engineering is at the forefront of some truly groundbreaking stuff. But let's try to break down a few of these in more detail. Where do you want to start?
How about we kick things off with sustainable and renewable energy?
Sounds good to me. Finding cleaner, more sustainable ways to power our world is a no-brainer. So what role does mechanical engineering play in making that happen?
It's essential. Mechanical engineers are the ones on the front lines, designing, building, and refining the technologies that harness these renewable energy sources. Take wind turbines, for instance.
Those giant windmills you see popping up everywhere.
Exactly. They might seem simple from a distance, but those things are incredibly complex machines. Mechanical engineers are the ones figuring out the perfect blade design to capture the most energy from the wind. They're determining the best materials to use to withstand extreme weather conditions. And they're developing the most efficient ways to turn that kinetic energy from the wind into electricity we can actually use.
Wow, so it's a lot more than just sticking a giant fan on a pole. There's serious engineering behind making sure those turbines are as efficient as possible.
Absolutely. And it gets even more interesting when you consider something called the Betz limit.
The Betz limit, what's that?
It's a principle that states that no wind turbine, no matter how well designed, can capture more than 59.3% of the kinetic energy that's actually in the wind.
Wait, seriously, there's a limit. So even with all our fancy technology, we can't capture all of that energy.
That's right. It all comes down to the fundamental laws of physics. But here's the really cool part. Understanding this limitation, this Betz limit, actually drives innovation. Mechanical engineers are always striving to design turbines that come closer and closer to that theoretical limit. They're finding ingenious ways to capture every bit of energy they can.
I love that. Even limitations can be inspiring, pushing us to find new and creative solutions. Okay, so we've talked about wind. What about solar energy? What's the role of mechanical engineering in that world?
Solar power is another area where mechanical engineering is indispensable. Electrical engineers focus on the photovoltaic cells that do the actual conversion of sunlight into electricity. But mechanical engineers design the systems that support and optimize those panels. They work on things like solar tracking systems that follow the sun's path throughout the day, making sure those panels are always at the ideal angle to capture the absolute most sunlight possible.
That makes a ton of sense. It's a real team effort, different engineering disciplines coming together to make renewable energy sources viable and efficient.
Exactly. It's all about collaboration, combining expertise from different areas to come up with the best solutions. And it's not just wind and solar either. Mechanical engineers are also heavily involved in developing those new energy sources we haven't even perfected yet. Wave energy, geothermal energy, even the holy grail of clean energy, fusion power.
Fusion power. The possibilities are mind-blowing. It's clear that mechanical engineers are at the forefront of developing these incredible technologies that could completely revolutionize our world. Okay, let's switch gears a bit and dive into another one of those future-shaping trends you mentioned, biomechanics and biomedical engineering. I have to admit, I'm not entirely sure what all that entails, but it sounds fascinating.
It's a truly amazing field. In the simplest terms, biomechanics is the study of how living things move, applying the principles of mechanics to biological systems.
So it's like how our muscles work, how birds fly, that sort of thing.
Precisely. And biomedical engineering takes those principles and uses them to design and create technologies that interact with the human body. We're talking about everything from artificial limbs and joints to medical implants, even the tools surgeons use in life-saving procedures.
Wow, so when we hear about designing an artificial heart, for example, that's where biomedical engineering comes into play.
Absolutely. It's an incredibly demanding field, requiring a deep understanding of both engineering and biology. You need to create devices that not only work flawlessly from a mechanical standpoint, but are also biocompatible. They have to work within the human body without being rejected.
Wow, that's a whole other level of complexity. What are some of the other big advancements happening in this field?
Well, we touched on 3D printing earlier, and that technology is revolutionizing biomedical engineering. It allows us to create custom-designed implants, prosthetic limbs, even artificial organs that are tailored to a patient's unique anatomy.
That's like personalized medicine on a whole new level. It's incredible to think that we can actually design and print body parts now.
It's pretty remarkable. And it's not just about replacing damaged body parts either. Biomedical engineers are also working on devices that enhance human capabilities. Think exoskeletons that help people with mobility impairments walk again, or even give workers superhuman strength and endurance.
That's straight out of science fiction. This is all so inspiring, but I need a minute to wrap my head around it all. Okay, I think I've had a moment to process all of that incredible information about biomechanics.
It's a lot to take in.
It really is. But before we get completely lost in the amazing future of mechanical engineering, let's shift gears a bit and talk about you, the listener.
Sounds good to me.
Because all of this incredible technology we've been discussing, it didn't just magically appear. There are some seriously talented people behind it pushing the limits of what's possible, and that's where the exciting world of mechanical engineering careers comes in.
Absolutely. A background in mechanical engineering can open doors to so many different jobs. And you're right, it's not just about working in factories anymore. This is a field that spans industries, from designing those sleek sports cars to creating life-saving medical devices.
So let's say you're listening to all of this and you're hooked, you're intrigued by this mechanical magic. What are some career paths you could actually explore with a mechanical engineering background?
Well, a classic role is that of a design engineer. They're the creative masterminds behind it all, using sophisticated CAD software.
CAD software.
Computer-aided design software. They use it to create detailed blueprints for everything. Everything from tiny gears to those massive machines we've been talking about.
So, like architects, but instead of buildings, they're designing the mechanical marvels that make the world go round.
That's a great way to put it. Then you have project engineers. They're the ones who take those designs and turn them into reality, overseeing every single aspect of a project, managing budgets, timelines, coordinating teams of engineers and technicians.
Whoa, talk about a high-pressure job. It takes some serious organizational skills to juggle all of that.
You can say that again. Now, if you're the kind of person who loves to push boundaries, a career as an R&D engineer might be the perfect fit. These are the pioneers, the innovators, who are constantly researching, experimenting, and developing brand new technologies, or finding ways to improve the ones we already have.
So they might be the ones coming up with those crazy new materials or making solar panels even more efficient. It sounds like a career path where you get to be incredibly creative and solve really challenging problems.
It absolutely is. But we can't forget about the importance of quality and precision in engineering. That's where our quality control engineers come in.
Right, because what good is a groundbreaking design if it doesn't actually work?
Exactly. Their job is to make sure that every product meets the highest standards. They identify defects, they conduct rigorous tests. They're always looking for ways to improve things to make them even better.
They're like the guardians of excellence, making sure everything is up to par, especially with all these new technologies.
That's a great way to think about it. And last, but certainly not least, we have the unsung heroes, the ones who keep everything running smoothly. Maintenance engineers.
Ah, yes, the fixers, the ones you call when something breaks down. They're the real MVPs.
They really are. They have the knowledge and the expertise to troubleshoot problems, make repairs, and keep those machines humming along.
It sounds like a career in mechanical engineering is anything but boring.
It's true. And that's something I always emphasize to anyone considering this field. It's not just about being a math whiz or a physics genius. While those are definitely helpful, the most important skills are analytical thinking, problem solving, communication, and teamwork. Those are skills that will take you far in any profession.
That's so true. So if you're out there listening to this and you love to tinker, figure out how things work, find creative solutions to tricky problems, well, mechanical engineering might just be your calling.
It might be.
Because at the end of the day, mechanical engineering is about more than just building things. It's about using your skills and your passion to make a positive impact on the world.
I couldn't have said it better myself.
And on that note, I think it's time to wrap up this incredible deep dive into the world of mechanical engineering. We've journeyed from the very first wheel to the mind-blowing future of biomechanics and beyond. Hopefully, you've learned something new, discovered a career path you never knew existed, and maybe even feel inspired to create something amazing yourself. So until next time, keep those gears turning because the world of mechanical engineering is waiting for you.